Alright, hello and welcome to today's video lesson on solving logarithmic equations. So today I will show you how to solve them in the calculator as well as by hand. So first off, we are going to look at a graph to find the intersection. So you've got log base 4 of x equals 1, and so we've graphed it and this is what we have. So if I'm finding the intersection is where they cross, which is at the point 4, 1. So how can this point be used to solve the equation? So if you look at the x value, because usually when we're solving, we want to get what x is. So your answer to this solution is x equals 4. Now how that makes sense, if I write this problem over here, we have log base 4 of x equals 1. If you turn that into an exponential, it would be 4 to the 1 equals x, which we know 4 to the 1 is 4, so x equals 4. So that is how you can solve it by hand. Or if you want to only do it in the calculator, you're going to look for the intersection, and then we only care about the x value. That will be your solution. This 1 comes from whatever was on the right side of the equal sign. So let's do some in the calculator. So let's pull out our calculator. Now when you solve by graphing, we've done this in every unit before. You're going to press y equals, and then you're going to type in the left side into y1. So the natural log is to the left of 4, natural log of x. Now then go down, in y2 you're going to type whatever is on the left or right side of the equal sign. So step 1, and then look at the graph. So press graph. Here's what we have going on. Now if your screen does not look like mine, first thing you're going to troubleshoot is to press zoom, and you want to go to the standard graph. So if you press zoom and go to 6, that will give you this normal 10 by 10 grid. And so now I just need to know the intersection. Now clearly that is not a nice number, that is a decimal of a sort. So it says round to the nearest thousandths, and then I wrote the steps that you're going to press in the calculator. So you're going to press second trace, intersect, and enter 3 times. So hit the blue button second, and then trace is up here. Now I want to find the intersection, so you can either scroll down to 5, or you can actually just press the number 5. That's faster. Now there is no blinky dot on my screen. So the function is to the right, so if you hit this right arrow, then your blinky dot will appear. Does not matter where the blinky dot is. So it's going to ask you 3 questions. First curve question mark, so you hit enter. It'll say second curve question mark, you hit enter. Guess question mark, yes you want it to guess, so hit enter one more time. And there is our intersection. So it's at this value of an x at a -1. Again, it will always be whatever was on the right side. And then our x value, so we're done. So we're just going to round that to 3 decimals, so 0.367, just kidding, that would round to an 8. It was almost a joke there. So again, this works for finding approximate solutions. So obviously this answer is not exact. So if it wanted you to find an exact answer, we could not necessarily graph this one, but approximate is good. So let's try this next one. Again, log base in the calculator is not a very easy way to find it. So it's not this log button. Again, log base is under the math button, and if you go up, it's actually faster. So you're looking for log base. Log base 5, and then type x in parentheses. And then on the right side, we had 1/2. So 1 divided by 2, or if you wanted to make it 0.5. So now we're going to press graph, and there is my 2 graphs. Again, the intersection, roughly maybe about right here. So to find the intersection, you're going to press second, trace, and then you're going to scroll down to intersect, or press 5. And then again, you don't have a blinky dot, because your blinky dot kind of sits at 0. You want to move it to the right, because the intersection is to the right. Doesn't matter where, hit enter 3 times, boom, 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 and there is your intersection. So 2.236. is our answer. So solving by graphing works for almost every single problem. It does not really, in our case, work for a natural log, because for our examples, we want natural log to be an exact answer. But every other problem we do should be a nice number, except natural log. So that is how you solve by graphing. And again, that works on all these. But let's move it on. So let's talk about solving logarithms. So, fun fact, the domain of a logarithm has to be positive numbers only. So any quantity that results in taking the log of a non-positive number, aka a negative number, would be called an extraneous solution. So for example, let's get out of our graph. If you press log, favorite number right now, 67. If you type log of negative 67, it doesn't work, because you cannot take the log of a negative number. Very much so how in Module 4 we could not square root a negative number. That is the same thing for logs. So we always have to check our work, because if you end up getting an answer and when you substitute it back in you get a negative value, then it would not work. And again, that is what's called extraneous. So we're going to do the first one. So I have the natural log of 4x minus 7 equals the natural log of x plus 5. Now this one is not bad, because if you have a natural log or any log base of the same thing on the same side, they end up canceling. So they cancel and you're left with the quantities that are on the inside. So now we just have to go back to Algebra 1 and solve this equation. So there's 4 correct steps to start this off. I like to subtract the x's and move them to the left first, personal preference. 4x, take away x is 3x, drop down negative 7, and then drop down your 5. I like to move my quantities or my numbers to the right side. So I'm going to add 7 to both sides. 3x equals a 12. Last step, divide by 3. So x is equal to 4. Okay? Now, again, 4 is a positive number, but if I plug it back in and get a negative number, it would not work. So let's check our work to the side. I would have the natural log 4, and then my x value was another 4. Take away 7. So that's what I would get after plugging in this 4. On the right side, I'm going to substitute 4 in, so I'd have 4 plus 5. So now I just need to do some mental math. I know 4 plus 5 is 9. So now we can either type this in the calculator. I'll go ahead and do that, show you guys. 4 times 4, take away 17, is in fact, I typed 17, I don't know why I did that. Delete. It's a 9. So you would have natural log of 9 equals natural log of 9, which is true. So I know 4 is a true answer, it's not extraneous, and that's the solution to my natural log equation. All right, let me show you how to graph that in the calculator. If you're like, nope, Mr. Tor can't do any of that, hopefully we can at least graph it in the calculator. So again, you would go to y equals. You would type natural log 4x minus 7 into L1. Type in the other side, natural log of x plus 5 into y2. Now if you look at the graph, there's your 2 log functions. The intersection would be right about here. Again, I know the answer is 4, so it's 1, 2, 3, 4. But to be exact, if you hit second trace, press 5. Now again, your blinky dot's chilling at 0. You need to move it to the right. You have to hit the right, I feel like 20 times. Nope, not many. Once you get the blinky dot on your screen, hit enter 3 times. And again, it tells you the intersection. Again, we're only solving for x, so we don't need this y value, but you have x equals 4. Okie doke. Let's try another one. I'm going to erase this check work. So the next one looks different, so I cannot do the same steps that I did for my left problem. So this is a log. Ask yourself what would undo a log, which is an exponential. So if I turn this problem into an exponential, I would have 2 to the third equals 5x minus 17. So turning your problem into an exponential will get rid of that log. So now I've got a normal algebraic equation. So 2 to the third power, 2 times 2 times 2 is 8. And again, regular two-step equation you guys have been doing since middle school. So we want to get the numbers on the same side. I'm going to add 17. We get 25 equals 5x. Divide by 5. So x equals 5. So again, if you're like, nope, didn't want to do any of that by hand, you could have graphed it in the calculator. You would have typed log base 2, 5x minus 17 into y1. You would have typed 3 into y2. Second trace, da-da-da-da, you get your answer. Now again, we do need to check our work to make sure this is not an extraneous solution. So you would have log base 2, 5, then your x value is another 5. Take away 17, and I want to make sure that equals 3. Because that's what it was right there. So 5 times 5, 25. 25 take away 17 is 8. So this turns into log base 2 of 8 equals 3. Now if you wanted to, you could type in log base 2 of 8 in the calculator. Again, we'll kind of show you that. Brush up on our calc skills. Again, that is under the math button. So log base 2 of 8 is 3, so I know my answer is correct. Also, if you wanted to do some log math, we know that 2 to the third is 8, so it checks out. So lots of ways to check your answer. So this is kind of level 1, level 2 of solving logarithms. Not too bad. We haven't had any extraneous solutions yet. So we're going to level up on the back. But that's for part 2 video because I'm about to run out of time. So thanks for watching part 1. Go ahead and head to part 2 where you will learn how to solve.